Well, welcome to another DevNation Tech Talk. We're going to have a lot of fun today, and I'm actually very excited to have all you guys here, and I thank you for showing up, and hopefully you enjoy this recording or this live stream if you're with us live right now, because we're actually going to have a lot of fun. We're going to be talking about machine learning with Apache Spark, and that is some really cool technology, and more importantly, it's how you can even run it on Linux containers, run it on Kubernetes, run it on OpenShift with a very interesting technology that Erik is going to introduce us to. Now, this is an important topic, I believe, because normally, if you've seen our previous presentations, we're telling you all about this great Java stuff and hardcore Kubernetes. We're showing you Knative and Istio and all this crazy deep dive technology, but not in the world of data analytics, not in the world of big data, not in the world of AI and ML. And Red Hat has a number of experts on these technologies and terminologies, and you're going to see some of that today. With Erik, who's up first, Sophie, who comes up a little bit later, and if you look forward to next Thursday, we're going to have Ioana as well, and Pete, who are going to show us even more of the same technology and take us down this path of what it means to be doing streaming analytics, big data analytics, machine learning, AI, artificial intelligence on a Kubernetes backbone, on an OpenShift backbone. So I'm excited to be here. Now, at this point, I want to turn it over to Erik, because Erik is going to give us the good stuff. Erik, over to you.
Hi, thanks everybody for coming. My name is Erik Erlandson, and I work under Red Hat's Artificial Intelligence Center of Excellence. The particular group I work for is the Forward Deployed Engineering Group, and basically we help enable customers to spin up applications enabled with machine learning or artificial intelligence in the cloud. So I'll be giving a deck and a demo a little bit later. I'm going to share my screen. Whoops.
Looking for that share button.
You know, it makes me do this twice every time. Okay.
There we go.
If you can't see my screen, please let me know. So you can see that I have email and both Twitter and Mastodon handles here. If you want to reach out to me afterwards, please feel free. Today I'll be talking about machine learning on Apache Spark with Kubernetes. So I want to spend some time putting a lot of this into context. There's a great paper called Hidden Technical Debt in Machine Learning Systems. You can see the reference at the bottom. But if you look at this little black box, this essentially represents the role of actual machine learning models in a larger system. And so you can see that true machine learning in terms of deploying learning models like neural networks, deep learning, decision trees, etc., is a very small component of a true application system. However, it can have an outsized influence on the rest of the components. Today, I'm actually not going to be talking very much about learning models. I am going to be discussing more the aspects of data collection and federation, and also feature computation. So we can also look at machine learning enablement for applications as a workflow. You start by, essentially establishing business goals, doing your data collection, do your feature engineering, and then your actual model training. This is the part where when people talk about machine learning, tends to be the part that gets a lot of press. And then, of course, afterwards, you have to do things like model validation, deploy the model, and then when it's in deployment, do monitoring. You can see that a lot of these processes involve feedback loops as you go through your development and operations. And again, to put what I'm going to be talking about in the context of this diagram, we're looking kind of like towards the left end in the realm of data collection and computing features. So what does that mean? I adapted this slide from a lab that we do where you actually create a little prototype spam filter. So an example of what you might do when you're doing data collection is assemble data representations of a bunch of emails or other social media streams, and actually collect the text from it and assemble it so that you can do ordered computation to train models on. Likewise, feature computation or feature engineering is taking these objects that you've assembled and translating them into vectors, arrays of numbers, usually. Occasionally they can be symbols, but these are the actual data structures that almost every machine learning model trains on and then evaluates. We can take a third perspective on all of this in the form of personas. So if you look at the process of doing DevOps for applications enabled with machine learning, you have data engineers who are assembling data and operating transforms to compute features on them, like we saw in a couple slides ago. They interface with data scientists who also obviously have a big interest in how the features are being computed and assembled. They do the training, and then, of course, you actually have to hand it off at some point to application developers or IT, where they take, the raw materials and actually deploy these things for end users. So again, the components that I'll be talking about today sort of live on the left here, intersecting with data engineering particularly, where you're looking at doing transforms on data to compute features, and you're also looking to actually federate disparate data sources to pull together all the stuff that your machine learning models are going to need. So one of the tools from the data science community is extremely good at these kinds of operations on the data end of the application development lifecycle is Apache Spark. And I want to talk a little bit about how Spark views both data and compute. The key thing to understand is it presents a logical view of your application and data, where you have a single application running and data sets are, a single sequence of data objects. In this case, it's just some integers. However, under the hood, it produces a physical view where you have a driver process, which is running your main application business logic. However, it's farming the bulk of your computing off to individual executors, and each executor is actually handling one partition of your data. So physically, your data is actually broken up into pieces that may not even reside on the same computer, and it's being operated on in parallel by these executors. So you get a lot of scale-out compute with this kind of model. How does this work? Let's imagine we take our application, and we want to apply some function to our data. In this case, we just want to multiply all our numbers by 2. So what does Spark do with this information? First thing it does is it takes the function we want to apply and it ships it off to all the executors so they can operate on it in parallel. And then individually, each executor runs that function, and so here you can see all their numbers have been doubled. Now, if you take a look at this and imagine what it's like to run a Spark cluster on Kubernetes, you can see it's a pretty good fit. The actual driver process runs in a pod, and every executor in your cluster, however many you have, also runs in its own pod. So it's a good fit for cloud-native development. Now, Spark has a feature that they call structured streaming, and I'm going to be talking a lot about structured streaming today because it's actually an extremely powerful data federation feature. If you look over on the right, suppose I want to do something very typical of data analytics. I just want to take some data, group it by some value, in this case a user ID, and then take some word counts in this case and just take an average. So this is a very classic, database aggregation operation. And this is what it looks like to do this on a static data frame. There's just a static table living somewhere at rest on the system. However, the key value proposition for Spark structured streaming is that, as we all know, data is not always just at rest in modern systems. It can also be, taken off streaming like something like a Kafka stream, or attaching to, streaming feeds like Twitter or other social media. And so you can see that we can do exactly the same computation with minor modifications, basically telling it using a write stream method, which tells it I'm operating on streaming data. But you can see that the data itself looks exactly the same. It uses the same schema. And the code that we wrote to do the aggregation is, byte for byte the same code. And so by presenting this kind of unified API, it makes it very, very easy in a data context to unify things like data at rest, streaming data from different sources. If you're interested more about how Spark structured streaming works, this link here will take you to a talk I did at Spark Summit that focused on some of the internals of structured streaming, the mathematical principles behind how it actually operates. So, as a developer, here are some of the benefits of structured streaming. You have a single unified interface to anything that basically is tabular data with a schema. You can back that with things like flat files, like just straight CSV files or Parquet. You can also back it with SQL, so essentially any SQL vendor provides drivers that Spark can use to present this API. Again, as I mentioned, you can back it with streaming data sources like Kafka, which I'll be using today in the demo. And there's an enormous number of data sources that provide interfaces that Spark can use to wrap a data frame interface around. So chances are, if you have a data source, there's a way to wrap a Spark data frame around it already. Now, on the consumption side, you can operate on these data frames using SQL inside of Spark. We'll be seeing that in the demo. Likewise, you can use Spark's native data frame API operations. There's an awful lot of overlap between what you can do using the data frame API code and actual SQL code. And importantly, you can also actually define user-defined business logic. And as long as you use the correct functions to wrap it in a way that Spark's structured streaming understands, you can essentially apply any business logic to the same API, including things like if you train a model, you can wrap the model inside a user-defined function and run machine learning inference straight on database queries. I've done this at some customers recently. So the demo that I'm going to be running is actually constructed on top of Open Data Hub. Now, Open Data Hub is an upstream community that Red Hat participates very actively in, and it essentially functions as a kind of reference architecture for artificial intelligence or machine learning applications running on OpenShift. And again, I will put the topics I'm covering today in the context of this architecture diagram. I'm going to be using Kafka, and particularly the Kafka Strimzi operator. I'll be attaching to a Postgres database, and at the higher level, the particular user activities is going to be in the data analysis end of it. So it's basically big data processing and streaming data. I'll be showing you what some of this stuff actually looks like running in OpenShift. So I'm going to skip out to the demo. So here we have a Jupyter notebook. Now, I'm not entirely sure how many people know what Jupyter notebooks are, but they've become sort of like the de facto user interface experience for a lot of data science. And most of Jupyter usage happens in Python. So today you're going to be seeing some Python code. If you don't know Python, that's okay. I'm really going to be focusing on the data federation aspects of it. So the first thing you can see here is I've attached to a Spark cluster. So I'm interfacing with Spark through Python running in Jupyter Notebook. And if I go over here onto OpenShift, we can look at the pods. So here is the actual pod that's running that Jupyter Notebook that I'm. And if you look down here, Open Data Hub automatically spun up a Spark cluster for me. So you can see that this is the Spark driver process, the worker node. And then there's two, somewhere here, there's two workers. Here's the strimsy operator, which I use to spin up Kafka. I'll be talking about the Kafka in a little bit. So I'll return to my notebook. So the first thing I'm going to do is just load up one of these data frames I just talked about. And here you can see I'm actually taking it from a CSV file. So this is an example of just attaching to a raw data file and wrapping one of these data frames around. And if I show it, you can see that this looks like credit card transaction data. So this is the kind of data you might see at any major credit card company. It's got user IDs, the merchant ID, some transaction amount, and some information on what kind of transaction type it was and whether it was to a foreign country. In my user scenario here for this demo, I want to translate these raw IDs, user IDs and merchant IDs into some names. So I have some other data tables. In a real system, these probably would be much larger and reside on a database. I'm actually just sort of constructing them on the fly here. So I have some names based on dogs I used to own. And some merchants. In this case, there's only 10 names and 15 merchants. Obviously, a real company, these would be into the millions. And I can register these so that Spark can also treat them using straight SQL. So here I've actually written some standard SQL that does a table join, and all I'm using here is a join operation so I can translate these user IDs into actual names for the user and the merchant. So I set up the data frame. You might notice that it computed instantly because Spark doesn't actually do the compute until you force it to. So here I'm going to show stuff, and now it's actually got to run the computation. So it's executing that SQL to show me the top 5 records in the data. And I can see it looks very much like the data I saw before, but instead of IDs, I have actual names. Just took the transaction type and the amounts from the raw table. So when I have that, I can then take it and run a classic, analytics aggregation. I can group everything by the user name and then look at the average transaction amount per user, and then I can sort it in decreasing order. You can see who's got the highest average credit card transactions and who's got the lowest. And similarly, I can run the same kind of aggregation using merchants. And so here you can say, okay, if I wanted to say what kind of merchants do the largest number of transaction averages, I can get that information very easily. So now suppose we didn't want to attach just to a flat CSV file. Suppose we wanted to run exactly the same computation but retarget it towards a SQL database. Spark can attach to essentially any SQL database that provides a driver. So in this case, I'm spun up a Postgres pod inside my namespace over on OpenShift, and I'll be using the Postgres driver. I have a blog in next.redhat.com coming out that actually talks about the details of what it's like to use these JDBC drivers in Spark. And I've loaded the same data into Postgres. So here you can see that I'm just attaching the same data frame interface. In this case, I'm pulling it off of a Postgres database. But you can see it's exactly the same data. And likewise, I can run exactly the same SQL. The only thing I did was change the name of the table to the one that I attached to the SQL database. You can see that the names have been changed from IDs. And I can run exactly the same queries that I did to aggregate, and it all works. So again, you can see the power of this data frame structured streaming API for taking your code and easily retargeting it to very heterogeneous data sources. So these first two examples were from data at rest. So structured streaming can also attach to streaming data. So here I have going to set up a computation where it's exactly the same data frame again, but it's taking it off of Kafka. So of course, in order to do that, I actually have to start producing some Kafka data. So I'm going to go over here to this notebook, and all this does is take that same data file and push it to a Kafka topic. So now that's running, and I can then start up this stream. And again, I can register this as a SQL table. So even though it's streaming data, I can apply standard SQL that looks exactly like the SQL up above. And I can create streaming queries. These streaming queries look a little bit different because I have to give it some additional information about what the streaming handler does to it. However, if you look up here, you can see that it's exactly the same group by statement. I'm grouping by username, taking the average, a transaction amount, and the same similar one using merchant name. So I can kick these off, and they do not output anything directly, but they are outputting to some tables I gave it. So here, is the results for merchant is being output to a table. And typically, you would be accessing this through some kind of other process. I'm doing this in a Jupyter notebook just so you can easily see what's going on. So if I look at those tables, you can see that, first of all, they haven't been well populated yet. One difference with streaming applications, of course, is that it's going to be aggregating my results as they come in. So you can see that right now these tables don't have a lot of data in them. But if we go back and read them, see that now they've started to populate. And these results are essentially results partial up to however much data we've actually seen from the stream. So every time you do this, you're going to see a slightly different looking result. However, what's key is the form of the result is exactly the same. Take these aggregated tables and use them in exactly the same context as you would with static data. If we go over here and look, the Kafka cluster that I was running this on also exists in my workspace, spun up using Open Data Hub. So you can see that it automatically gave me Kafka Zookeeper. Here's the actual message buses. So here's the individual highly available redundant clusters for pods running Kafka for me. And again, all this is installable using the operator hub from OpenShift. So you can spin this stuff up very easily. Use the operator catalog right here. So here, if you look in Operator Hub, you have lots of different operators you can put in. And under Big Data is the Open Data Hub operator. That's how I installed this to run this demo. So that is the conclusion of the demo. I'm going to then just stop my streaming queries. Also tell my producer to quit. And that is the demo. Thanks again for coming. And if you have any questions, I'm happy to take them.
Yeah, we do have some questions, and one right quickly from Rolando down in Bolivia. He wants to know if he can get access to your notebook and maybe the CSV file, and like you can check it into GitHub and he can hack on it himself.
Yes, in fact, I actually already have it checked in. I was going to add some documentation to that notebook. I haven't done that yet, but it is actually already available up on GitHub. And yeah, Bert, how do you want me to share that? I mean, I could share my screen and show them where it is, but I can also circulate it afterwards.
I tell you what, send it to me afterwards, and people have my email address. They get an email from me to announce the session. And then also put it on your Twitter. I sent the link to your Twitter account to everybody, so they should be following you on Twitter. And so you tweet it out, email me. People can email me for that. I think that would be awesome. And now there's some things I also have a question about, because I haven't looked at Apache Spark in a long time. I actually have the book still downstairs right over there that basically says how to learn Apache Spark in like 24 hours or something like that. And what you showed me some things I hadn't thought about for a while. One, I love the input of the CSV file, right? That's a pretty common thing. You get the CSV file out of numerous systems, legacy systems otherwise, and it exports the CSV file. You got to gather those up, and you got to start basically ripping through them. That's how I look at it. But I didn't realize it had a SQL-like interface to essentially do a select and join and group by on that data set. Can you describe that a little bit more? Because it was interesting to see you use the exact same syntax on a CSV file, a Postgres database, and a Kafka resource, all with Apache Spark.
Yeah, I mean, I think that, this is a somewhat underappreciated capability of Spark. In fact, I think that the structured streaming interface is maybe Spark's most powerful, useful feature. It really, really shines when it comes to, operating on tabular data for multiple sources, and just being able to easily retarget different sources and federate. I can show my screen again if you want to look at the code, if that's what you were thinking.
Yeah, feel free to pull it back up, and if there's a...
Yeah.
Because another thing that surprised me, too, is it hadn't occurred to me, you use the Jupyter Notebook to drive messages into your Kafka queue and Kafka topic, and then you had your other notebook to receive that data, right? So you had your producer and consumer both running as two different notebooks. I had never considered that before.
Yes, this is definitely not how you would generally want to produce data, but if you're interested in doing something like just do test beds or demos, it's actually kind of useful because you can show people the code. So you can see it didn't take much to push this over Kafka. I just had to attach to the cluster here the standard broker. This is the actual service name from OpenShift.
Okay.
So it makes it really easy to attach to. And then I just loaded up. Yes?
That's just a bootstrap server. If you do a OC get services, that's exactly what that is with the 9092.
Yeah, this is all very standard. And let me show you this. I mean, like, again, the operator, the Strimsy operator automatically spins up some nice stuff for you. It doesn't just create the pods. It actually, we get under networking, it exposes Kubernetes services, and it exposes all the individual message buses, but it also exposes the Bootstrap server here.
Okay. So a fun question related to what you're showing now, perhaps, is what if I wanted to actually have one of my input sources be Hadoop HDFS? And can I use what you're showing us with that as an input source and combine that with my Spark and my notebooks?
Oh, yes. Yeah. I mean, in that one slide, I had the ... There's really hardly any relevant data platform that Spark can't connect to. So like if you look at what it looked like to attach a data frame, yeah, so I mean, this here dot format is kind of like how you control that. Here I'm just telling it, look, you're going to connect to a Kafka, and then of course, because it knows it's Kafka, it says, oh, there's some different parameters, like here's the Bootstrap server name, here's your topic you want to subscribe to, and when you want to start the data offset, and there's all the usual Kafka connection parameters. But it can read, a lot of other stuff too. Like if you actually look at how I did this up at the top, it can attach directly to a CSV file. If you look at what I did here, I was actually cheating a little bit. I was using Python pandas to read the CSV file, but it actually showcases another thing you can do. If you can tell Spark to create one of its data frames directly from a pandas data frame.
Right.
So in this line, I'm basically sucking a CSV file into pandas, and then I'm sucking the pandas data frame into a Spark data frame.
Okay. Well, a couple other questions from the audience, and then we have to finish up this stream and get ready for the next one. But one question that is, have you ever used like MLlib with Spark or Apache Spark's MLlib? And do you have any?
Yes. I have. I think, like at least in our group, the way we conceptualize these workflows now is we tend not to do machine learning directly in Spark. However, it is a good point that Spark absolutely can, you can absolutely train learning models inside of Spark, and Spark has got development efforts underway that are available in its more recent versions, and especially in the upcoming 3.0 release, that are even going to support sort of non-standard compute models. And I say non-standard relative to Spark's typical compute models, so that you can train TensorFlow models directly inside of Spark. That's obviously outside of the scope of this morning's talk, but you can definitely do learning model training in Spark using Spark's MLlib or its interfaces to other third-party projects like TensorFlow. Again, we in our group tend to view Spark's real strengths as more in this back-end stuff that I've demoed today. But yeah, it's an excellent point. You can do all of it.
So two quick questions, and we have to wrap up, but I want to make sure I get to a couple things here. So Rolando was also asking, okay, and this is an important one, I think. I see that you basically are using the Kafka producer, right, and the Kafka consumer inside your Jupyter notebooks. And so let's say I want to drive a dashboard, right? So literally the stream is constantly coming in, the notebook is constantly evaluating the data, and I want a dashboard out the other end showing me the real-time analytics in a graph form. How would I put this in a production setting? Are these blocks of code or what's going out into a production environment to be used by real end users?
That is a great question. As you can see, I was attaching the output of my streaming query just to another Spark data table. So there's a lot of options there. You can actually take the outputs of your streaming query and just say, dump my output back onto Kafka. So you could push your stuff back onto Kafka to consume it with other applications. Another version we've done is to put it onto things like in-memory stores like InfiniSpan. So we've taken the same kinds of aggregation results and just told Spark to push it up to InfiniSpan, so the third-party app can consume it that way.
He did ask about a cron job, so I'm wondering. So the Jupyter Notebook itself is literally in production, running all the time, or is there another wrapper or way you handle that piece of code so that it's more production ready to deal with this?
Right. So there's a lot of options there. I mean, data scientists will often work just exactly the way I showed the demo this morning. They spin up Jupyter notebooks and just use them as experiment environments or dev environments. However, we've also got technology that can take one of these notebooks and run OpenShift source to image builds on them. So it can take, this notebook code and repackage it as a runnable container that you can just spin up. I've done this for customers where I gave them source to image building technology to take their data scientist notebooks, repackage them as containers that attach to their databases and run the machine learning models that came out of the notebooks against the databases. So I think those are two modes you can do. Again, I encourage you to reach out to our group. We've actually got tons of materials, use case examples, and previous talks on like what happens with these notebooks and how they fit into a broader, DevOps flow.
Okay. Well, one last question I want to make sure we get to for Miguel, because he was asking about, he's a student working on a thesis, and so his question is fairly basic, and hopefully you kind of give him some nice parameters to look in. If all he's trying to do is figure out the classification of customers, what their buying preferences are, what kind of recommendations we want to make to them, right? That's a very common use case. What would be your kind of getting started point for that? What algorithms, what technologies?
I think that if you want to do that kind of basic, learning model experimentation, Python's sklearn is pretty good. XGBoost library is great. Obviously, all the major, differential computing platforms like TensorFlow, can be driven through these notebooks. And so you have an awful lot of tooling at your disposal. And again, if you want to back the computation with Spark, you can. A lot of work gets done just attaching to things like pandas data frames. And, again, like a lot of data science says, okay, I'm going to train my data using data I've assembled into a pandas data frame, but then I can do source to image to repackage the model in a form that just, knows how to attach to a, Postgres database or something like that. Because to answer your question is, if you're a student using Jupyter, and then, from Jupyter and Python, you can access basically most of the machine learning ecosystem.
Okay. And by the way, just one last question. Are you on the Open Data Hub mailing list, and that's kind of maybe another way for people to find you?
Yes.
Okay.
And you also we're all on the AI COE mailing list, reach a slightly broader COE community.
Okay. Well, and I can tell Sophie is now waiting on us, so she's just responded to a question in the chat. So, but I thank you so much. We're going to get Sophie warmed up here and get her lined up on the Blue Jeans thing. But Erik, awesome stuff. I love what you showed us there. Again, I've not looked at Spark in so long that it definitely helped me a lot get a feel for how it's working at this point in time with Open Data Hub on that Kubernetes OpenShift cluster. So thank you so much for that. And I bid you adieu, because we're going to sign off on this stream and set up the next stream where we'll see Sophie showing up here to talk more about Jupyter Notebooks and the world of the data scientist and how you can use these tools as well. So Miguel, you might want to come back with more of your questions about how to deal with that customer-related database that you had there. Thank you so much, Erik.
Thanks, Burr.